Hello friends, all of you are welcome again on Science Valhalla channel. And we will look at some important piecewise defined functions. What are piecewise functions? Sometimes it is necessary to define a function by using different formulas on different parts of its domain. Such functions are called piecewise defined functions. Keep in mind, I said, on different parts of the domain. Okay, if you do not understand, then wait a little while, we will draw the graph, then you will be able to understand it easily. Now let's see how to draw the graph of piecewise functions. First, here we have the absolute value function. What kind of function is an absolute value function? Algebraically, for whatever the input value is, the output is the value without regard to sign. This means it always gives a positive number. As distance is always a positive number, distance can never be a negative number, so it will be very useful if we consider distance as the absolute value function. We will divide the function into two pieces. The first formula is x, if x is greater than or equal to 0. And the second formula is minus x, if x is less than 0. This is how we have defined this absolute value function. Y is using two different formulas on two different parts of its domain. Let's draw a graph of this. Before graphing it, it has to be kept in mind whether the endpoints of the domain are included or excluded. So our focus should be on that too. Secondly, we will show the included points with a solid dot on the graph and the excluded points with a hollow dot. Now we start to draw the graph. For this we will first take the first formula. Since the domain x is greater than or equal to 0, so we can only input 0 or greater values in it. So we make a table of inputs and outputs. And we plot these points on the graph and join them with a smooth curve. We will take the second formula and make a table of its inputs and outputs according to its domain. And we plot these points on the same graph and join them with a smooth curve. In this way, we get this absolute value function, can see the graph. Another example is the Heavyside function. This function can be used to model the voltage applied to an electric circuit by 1-volt battery, if a switch in the circuit is closed at time t equals 0. This function has two formulas. The first formula is 1, if x greater than or equal to 0, and the second formula is 0, if x less than 0. Let's draw the graph of this also. Take the first formula, its output will always be 1, when x is equal to 0 or greater than that. Because it also has 0 in its domain, then the point 0, 1 will be included in it, right? Now we will take the second formula, its output will always be 0 when x is always less than 0. So the point 0, 0 is excluded. Let us now look at the third example, the Signum function. The name signum is the Latin word, meaning sign. The value of Signum function tells whether x is positive or negative. Since 0 is neither positive nor negative, the Signum function is not defined. Let's draw the graph of this also, taking the first formula. When x is always greater than 0, we will get 1 in the output, simple. Now we will take the second formula, when x is always less than 0, then the output will get minus 1. Now we see the third formula, when x becomes equal to 0, then it will be undefined. In this way, 0, 1 and 0, minus 1, both the points have been excluded, right? Let us now look at the fourth example, which will be very different from the rest of the three examples we have done. There are three parts to this function, as you can see. Because to draw the graph of this function, we have to make a table of input and output values, but I am skipping that process here, because you can do that easily now. I draw the first formula on the graph. Since its domain x is less than -1, then the point -1, 0 will be excluded. Now I draw the graph of the second formula. Since its domain includes -1, so the point -1, 1 will be included in the graph of the function, but x equals 1 is not included at the moment, so the point 1, -1 will be excluded in it. Let me draw you the graph of the third function. Since it has x equals 1 in its domain, it will contain the point 1, 0. So in this way we have seen that it is easy to draw graphs of piecewise functions. That's all in today's video. The rest we will see in the next video. If you like this video, then please like, comment and share. In the next video, we will understand about trigonometry function, which is very important. Till then, please subscribe our channel so that you can get notification of upcoming videos. Thank you.